Hello everyone, very good evening. This is Sanjay Rathi. So guys, now we have around 2 months for GATE preparation and 1 month for revision. That is month of January. Okay. So hope you have started your preparation for GATE and engineering services exam. Now guys, this is a smart revision series and I am going to deal with what diode circuits. Okay. And that is for GATE and engineering services exam and other competitive exams. So everyone please inform me that sound quality, picture quality, everything is fine. Yes, please. Diode circuits means what? Number of applications of diodes. But we are getting questions from 1 minute. Give me. Is it audible? Okay, everything is fine now. Now, diode circuit. That is part of analog. And we have number of applications of the diode like what? Rectifiers, clipper, clamper, voltage doubler circuit, okay, sampling gates. Then again in case of Zener diode we have the breakdown diodes, Zener mechanism, avalanche mechanism. So this is a very important topic for all competitive exams and we are getting number of questions and but today we are going to discuss what simple diode circuits. Simple diode circuit means ideal condition, practical condition, right? Large signal models. Okay, this type of questions we are going to discuss. And guys, in some circuits, multiple diodes are connected. 2 diodes, 3 diodes, switches are connected. So what are the positions of the diode, whether they are on or off, we have to check. So this type of questions we will solve. That's why this session is important. You will get the basic idea about the diodes and how to deal with the question based on what diodes. So you see, it is a smart revision series. Transform your way of preparation, right? Is it okay then? तो आप ट्राई कीजिएगा सॉल्व करने के लिए अपना पेन कॉपी कैलकुलेटर ले लीजिए, वर्चुअल कैलकुलेटर एंड ट्राई टू सॉल्व ऑल दीज क्वेश्चंस. ओके, अगर आप रिकॉर्डेड सेशन वॉच कर रहे हैं तो भाई जो भी क्वेश्चन आता है पहले पॉज कीजिए, क्वेश्चन बनाइए एंड देन गो फॉर सॉल्यूशन. आप अगर वीडियो देखते रहेंगे तो हो सकता है शायद आपको क्वेश्चन समझ में ना आए, लेकिन अगर आपने क्वेश्चन अटेम्प्ट किया और उसके बाद अगर आप सॉल्यूशन देखते हैं तो ये आपका कॉन्फिडेंस बूस्ट करेगा अगर आपसे बन जाता है तो. ओके, चलिए स्टार्ट करते हैं. डायोड सर्किट. फर्स्ट ऑफ ऑल दैट इज माय इंट्रोडक्शन. 24 years of teaching experience. These are my ranks, AIR 16 and AIR 21 in ESE, that is Engineering Services Exam conducted by UPSC. I worked as Deputy Director in Ministry of Power, right? And I got offer from Ministry of Railway also, right? Naval Armament Services. Then this is my experience. Then guys, I'm going to start complete revision of what? Digital. Complete revision of digital. This is for what? Computer science, IT, electronics, electrical, instrumentation branch. From number system to up to what? A to D, D to A converter. Here we will cover what? Number system, then diodes, then Boolean algebra, then what? Combinational circuits, like what? Multiplexer, decoder, demultiplexer, adder, right? 4-bit binary ripple carry adder, and what? Then sequential circuits. Sequential circuit means what? Registers, counters, synchronous counter, asynchronous counter. So this is the session. Link is given in description. So what is the weightage of digital? What are the important topics and complete schedule of digital, guys. So stay tuned with me. On same channel we will complete digital with theory plus what? Complete numericals, right? To concept with numericals. So on the same channel, to first of all subscribe the channel and inform your friends about this. अगर आप enjoy कर रहे हैं तो definitely इस सब्जेक्ट में आपकी कमांड हो जाएगी और ये क्वेश्चन ये सब्जेक्ट एक इंपॉर्टेंट रोल प्ले करता है. क्या होता है इससे ना? आपका कॉन्फिडेंस बूस्ट होता है जब आपकी एक एक करके सब्जेक्ट में कमांड होते जाती है. तो यहाँ पर कंप्लीट रिवीजन होगा. आ जाइए, सब्सक्राइब कर लीजिएगा चैनल को. देन वेरी गुड इवनिंग. देन अब आते जरा व्हाट इज द एनालॉग एंड सो ऑन. तो रामो, हाउ आर यू? वेरी गुड इवनिंग. नाउ फर्स्ट ऑफ ऑल go through the syllabus of the analog circuit. So number of topics, guys, quickly. Number of topics. First is what? Diode circuit, rectifier, filter, precision rectifier. But guys, on diode, we are getting questions from basics of the diode. Basic diode circuit means single diode, multiple diodes, right? So we are going to solve this. Then I will arrange session for rectifier, filter, then precision rectifier. Precision rectifier is with operational amplifier. Then clipper, clamper, voltage doubler, voltage regulator. Now after that, BJT, MOSFET, multi-stage amplifier, and frequency analysis, feedback amplifier, oscillator, power amplifier, operational amplifier, waveform generator, linear wave shaping circuits. This is the syllabus of analog. But one of the most important topic is what? Diode circuit. So we will solve questions on diode circuits. Then to try to solve this question, that is the question from standard textbook Sedra and Smith. I think you have the books. Okay, so this is the Sedra and Smith. I have 6th edition. This is the Sedra and Smith, guys, and that is the question from Sedra and Smith. And we are getting this type of question, basic questions. So first question is, find the labeled voltage and currents in figure A and B. A and B, there are two figures. Labeled voltage and current means this is the, you have to find the V and you have to find the I, right? And assuming that the diodes are ideal. Simply diodes are ideal. For ideal diodes, how you can solve this? Now, very basic question. Try to give me the answer for these questions, right? If you are watching the recorded session, right, not live session, then stop, try to solve and then go for solution. And live students, try to solve this. Then this is 12 kilo ohm resistor is connected, 6 kilo ohm resistor is connected. So what is the difference between these two diagrams? First of all, watch carefully. In these two diagrams, diodes, position of the diode same current, same voltage, battery is same. What is the change? Only the change in what? Position of the resistor. Here 12 kilo ohm is connected, 6 kilo ohm. Now 6 kilo ohm, 12 kilo ohm. So that resistor are going to play what? Important role. That is called what? Crucial role. Okay. So, because of resistor, there is change in what? Voltage drop across the diodes. Okay. Now, so first of all, first diagram, is it visible? 12 kilo ohm resistor, 3 volt, V and 6 kilo ohm resistor. Then ideal diodes, guys. Ideal diodes, we have two conditions. If this is forward bias, it takes short circuit. What is the voltage drop across the diode? 0. If it is reverse bias, then it acts as what? Open circuit. Okay. Now there are two diodes. If there are two diodes, so what is the condition here? Both the diodes may be on. First condition, second condition, third condition, fourth condition. Both off. This is off, that is on. This is on, that is off. And both on. These are the conditions. 4 conditions are there, right? But because this is the 3 volt is connected and that is the positive terminal, and that's why this is not applicable. Both the diodes are off, not possible, because it is a positive voltage. Because of positive voltage, D1 may be on or D2 may be on. Any one of the diode may be on. So that's why this is not the condition. Now there are 3 conditions, second one, third one and fourth one you have to check. First of all, 3 volt. Because remember, you can assume, what you can assume, let both the diodes are on. Because of this 3 volt connected to positive terminal, you can assume let both the diodes are on. When you are assuming that diodes are on, always remember, current through the diode acts as short circuit and current through the diode should be positive. It should be greater than or equal to 0. It will not allow the current in opposite direction. It will not allow the current in opposite direction. And that's why the current, this current I, is never negative. Current will flow from positive to negative. So D1 is off and D2 is on according to Ramu. Now I will check. Now watch this. D3, because of this 3, let both the diodes are on. When both the diodes are on, one minute. Then watch this. This is connected to ground. That's why this voltage will become 0. This voltage will become 0. This acts as short circuit. This is minus 3 volt. This is the minus 3 volt, 6 kilo ohm, 12 kilo ohm, 3 volt. That diode is also on. Let this is on, this is on. Both on. What is the voltage at this point? 0. Now guys, what is the current here? 3 minus 0 by 12, 3 by 12. What is the current here? 1 by 4. 3 by 12 is nothing but 1 by 4 milliampere is the current from this point to this point. And what is the current here? 0 minus of minus 3, it will become plus 3 divided by 6, 1 by 2 current here. 1 by 2 current here. If this diode is on, what should be the current here? I. You have to calculate the I. So what are the incoming, what are the outgoing current? I plus 1 by 2 is equal to what? 1 by 4. This is the incoming current. So what is the I? 1 by 4 minus 1 by 2, that is minus 1 by 4. Negative, not possible. Not possible. Negative current, not possible. And that's why guys, this assumption is what? Wrong. This assumption is wrong. D1 is not on. Then what is the next one? This is cross. So now you can take the D1 is what? Off. When I am going to take the D1 off, then D1 act as what? Open circuit. D2 act as short circuit. This is 3, this is 3. And now this is the 12, this is the 6 kilo ohm. Again we have to verify whether the D1 is off, yes or no. So always remember, if any diode is off, then positive terminal voltage, this is the positive terminal voltage, should be greater than what, should be less than what? Negative terminal voltage. What is the negative terminal voltage here? 0. It should be less than that. We will verify. Now this is the case. What is the current here? 3 minus of minus 3. 3 minus of minus 3 upon 3 minus of minus 3 upon 12 plus 6. 18. That is a 6 by 18. 6 by 18. So what is this current? 1 by 3. 1 by 3. And what is the current here? 0. This current is 0. 1 by 3. Now what is the potential at this point? This is nothing but V also. What is the potential? You can find the Vp is equal to, or V is equal to 1 by 3 into 6. V is equal to 1 by 3 into 6, this 6 minus 3. And you will get minus 1 volt. Minus 1 volt. The answer for this question, what is the value of the V? Minus 1 volt. What is the value of the I? 0. Minus 1 volt. And the voltage at this point is minus 1, means Vp is less than Vn, and that's why this diode is off and our assumptions is correct. This is the second one. So you have given the right answer. D1 is off and D2 is what? On. Clear? So with practice you can quickly give the answer, guys. Quickly you can give the answer for this question. Very easy question. So this is the case. Diode D1 is off, D2 is what? On. And you, in this way you can verify. So what is the conclusion here? For any case, guys, if the diode is on, current through the diode in this direction should be greater than or equal to 0. If you are assuming that the diode is off, always remember that is the Vp voltage, positive terminal voltage, negative terminal voltage. Vp should be less than or equal to what? Vn, then we can say diode is off. If the Vp is greater than Vn, then definitely the diode will be on, forward bias. Ideal, that's why it will act as short circuit. Okay, first question over. Now second question. What is the second question here? Second question, guys, this one. Simple change in the position of the resistor. Simple change in the position of resistor. Now the 12 kilo ohm is replaced by the 6 kilo ohm and 6 kilo ohm is replaced by the 12 kilo ohm. Same battery, minus 3 volt, 3 volt, 6 kilo ohm, diode D1, diode D2. Now tell me, what is the answer? Now again, because of positive 3, both the diodes may be conduct or any one of the diode conduct, but that condition is not true. D1, D2 both off. It will not work. Any one of the diode may be on. Let again we are assuming let both the diodes are on. If you are assuming let both the diodes are on, D1 and D2 on, this is assumptions. D2 on, then what is the voltage at this point? It will become 0. It will act as short circuit. Then this is also act as short circuit. This is minus 3 volt. This is the 12. What is the voltage at this point V? What is the current you have to find? 6 kilo ohm 3. Now, if this is 0 volt, this is 0 volt. What is the current here? 3 by 6. What is the 3 by 6? 1 by 2. What is the current here? 0 minus of minus 3. It will become plus 3 upon 12, 1 by 4. So this current is 1 by 2. This current is what? 1 by 2 minus 1 by 4. What is the current here? 1 by 4. Positive current. 1 by 2 minus 1 by 4. That is the positive current. And that's why this diode is on. What about this current? 0 minus of minus 3 plus 12. That's why this diode is also on. So both the diodes are what? On, guys. Both the diodes are on. Right? And that's why, what is the voltage at this point? 0 volt. This is the 0 volt. So simply if you are assuming that the diodes are on, remember you have to check what? Current, I. So current is positive. What is the current here? 1 by 2. What is the current here? 1 by 4, 1 by 4, and total current is what? 1 by 2. Finished. Is it clear? So both the diodes are on. Value of I is 1 by 4. Value of V is what? 0 volt. What is asked in question, that is more important. Please take care of that. It may be MSQ, guys. For example, if first option D1 on, D2 on, B, current through the D1, 1 by 4, current through the D2, 1 by 4, you have to find the current, C, right? Current through the 1 by 2, 1 by 4, milliampere. Current is in milliampere because resistor is kilo ohm. So, and that is the D. The value of V, 0 volt. Now, this is the MSQ. If it is MSQ, then D1 and D2 both on, correct. ID1, this is the D1. What is the ID1? 1 by 4. What is the ID2? 1 by 4. That is also correct. This is wrong. What is the value of the V? 0. That is correct. So what are the answer? A, B, C. A, B, C is the answer for this. A, B, D, not C. This is the MSQ. Multiple select question. There is no negative marking in what? Multiple select question. So you have to attempt this type of questions, and that is the question from standard textbook, guys. Okay. Now, next one. So that is these are the two questions. Second one, multiple diode, another question. Find I and V in the circuit. Again, that is from what? Standard textbook. Tell me, what is the answer for this one? What is the answer for this question? There are 3 diodes, D1, D2 and D3. If these are connected, D1, D2, D3 are connected here, then what about the state of the diodes D1, D2 and D3, on or off? Now, and you have to find the value of the I and V. Then remember, if the positive side voltages are connected, always check the highest voltage. What is the highest voltage? 3 volt. Because of this 3 volt, D1 is on. Because of 3 volt, D1 is on. I always check the highest voltage. Once the D1 is on, this voltage will become 3 volt because it will act as short circuit. The voltage at this point become 3 volt. And that is a 1 kilo ohm resistor. So what about the second diode? On the negative side 3 volt, on the positive side 2 volt, and that's why this diode is off. Because its positive terminal voltage is less than the negative terminal. What about the third diode? It is also off because the 1 volt is less than the 3 volt, and that's why only the D1 is on. What is the voltage? 3 volt, and what is the current? 3 by 1, 3 milliampere. 3 by 1, that is the 3 milliampere is the current, guys. So very simple question. On the positive side always check what? Higher voltage. Higher voltage, 3 volt and 3 milliampere. Right answer? Yes. Now next one. Similar type of questions when we are getting on the negative side, guys. Negative side. For example, if you are watching on the inverting terminal, this is the VN. So always go with what? Lowest value. So it is a 1 kilo ohm, 5 volt is connected. On the positive side 5 volt is connected. But you have to, which one is the most probable thing, most expected is what? Lowest value, 1 volt. Once it is on, let the D1, D2, D3. Check the lowest value, let D3 is on. Once the D3 is on, it will act as short circuit. Okay, and now this value is what? 1 kilo ohm. This is the 5 volt, and this will become 1 volt. Output voltage will become 1 volt. Now what about this diode? On the positive side it is 1 volt, on the negative side it is the 3 volt. So Vp is less than Vn, that is off. 1 volt, this is the 2 volt, that is also off. So both the diodes are off. Because it is 1 volt, it is 1 volt, here it is a 3 volt, here it is a 2 volt, and that's why. What is the current? Current will flow through this diode. And what is the current? 5 minus 1 upon 1, that is the 4 milliampere. And what is the voltage? 1 volt. 4 milliampere, and that is the answer. Okay, simple question. 1 volt and 4 milliampere, good one, right answer. So quickly you can give the answer for this type of question. So multiple diodes. Now, last year there was a one question on multiple diodes, guys, and that's why I am giving you the idea about this. So we will solve that question. First of all, watch this. In 2006 there was one question, and again in 2024 there was a one question in electrical branch. So first of all, try to solve this question. Now, what are the states of the three ideal diodes of the circuit shown in the figure? Again, ideal diodes. What is the states means? What about the diodes? Whether it is on or off. So there are four options: D1 on, D2 off, D3, D1 off, D2 on, D3, D1 on, D2 off, D3 on, D1 off, D2 on, and D3 on. In 2006, it is of only of 1 marks question. Current source is given 5 ampere. D3 is given, 10 volt battery is given, D2 is given, and so on. Okay. What are the states of the diodes you have to give? कौन से on है, कौन से off है? Then now if there are 3 diodes, guys, total 8 conditions, just like a digital, if there are 3 diodes, guys, so what are the total condition? 2 to the power 3, 8. 0 0 0 means all are off. 0 0 1 means that is 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, and what? 1 1 1. There are total 8 conditions. 0 means off and 1 means on. So total 8 conditions. So if suppose in exam hall you are going to check the 8 condition, it will take what? More than 5 minutes. Right? So first watch the diagram carefully. Because of this 10 volt, and this is ground. Because of 10 volt, highest battery is the 10 volt, definitely this voltage is positive. If this voltage is positive and this voltage is 0, so what about the D1? Positive terminal voltage is greater than the negative terminal. If the positive terminal is greater than the negative terminal, then definitely this diode is what? On. This diode is what? On. Right? If you are saying that this diode is on, then what about these four conditions? Finished. Now you have to check only these four conditions. Because D1 is on, so 1, 2, 3 and what? 4. These are the applicable conditions only. So out of 8, we have to check only 4. Right? First condition. Second, now if this diode is on, try to understand. If this diode is on, this is short circuited. So what is the voltage at this point? 0. Now, if this voltage is 0, what is the voltage at this point? Positive or negative? Now try to understand. Think about it. 5 ampere current source or 1 volt, 1 ohm in parallel. So when we are going to convert it into what? A voltage source. Always remember, we can convert the current source into a voltage source. So 5 multiplied with the 1, 5, and that is what, so you can convert it into a current source. Then you can redraw the diagram like this. This 5 ampere is multiplied with the 1 ohm. So 5, I will give you the shortcut also. 5 into 1, 5 volt and 1 ohm in series. Now, what is the voltage at this point? 0, because it is on. Now it is a positive voltage, guys. It is a positive voltage. Because of this positive voltage, here it is a positive. 0 positive. That's why, what about this diode? Off. Positive 0. What about this diode? Off. So you can say both the diodes are what? Off. Right? Off, off. Right? Directly you will get the idea about this. Now, which answer is correct? D1 on, D2 off, D3 off. A is the correct one. A is the correct one. Now, but in exam they will ask what is the current through the diodes? What are the currents? So we have to verify. If you are assuming that this diode is off, that diode is off, means there is no current through the diode D2 and D3. What are the currents, guys? Now, if this is off, the 5 ampere current will flow here. 5 ampere current. This is the point. This diode is also off. Then from this point to this point, what is the voltage here? 0. From this point to this point, what is the voltage here? 0. Let this voltage is V. No need to calculate the V. But here we can divide the current. Here we can divide the current, guys. 1 ohm, 1 ohm, and that's why current is equally divided. 2.5, 2.5. 2.5 and 2.5. Okay. Otherwise, you can apply the nodal equation V minus 0 by 1 plus V by 1, V minus 0 by 1, and what is the incoming current? 5 ampere. Then you can find the V is equal to 5 by 2 divided by 2.5 volt. 2.5 by 1, that is the 2.5 ampere. 2.5 by 1, 2.5 ampere. Now, if it is asked, what is the current through the D1? What is the current through the D1? So watch this. This is the 10 minus 0 by 1. What is the current here? 10 ampere. 10 minus 0, 10 ampere. And what is the current here? 2.5 ampere. So 10 plus 2.5. What is the current here? 12.5. It may be the objective question. So normally what we are doing, just we are solving the previous year questions. Right? जैसे ये question आया. So what is the answer? Sir, A is the answer. अरे my dear friend, what about the next question? There may be the next question. Find the current through the I. इसका तो आपको solution मिल जाएगा. This is the D1 on, D2 off, D3 off. But next question will be what? What is the current through the diode D1? तो current, and that may be what numerical answer type question, numerical answer type question, NAT. So guys, before finding the I, you have to give that this diode is on, this is off, this is off. What is the current here? 5 ampere. This current is divided into two parts, 2.5, 2.5. This is the 0, and that's why this is the 10. 10 plus 2.5. What is the current here? 12.5. This is the positive current. Finished. What is the current through the D2? 0. What is the current through the D3? 0. Okay. Once the diode is off, there is no current. If you have any doubts, if you find any difficulty, if you want to give any suggestion, so you can give, right? At the end, I will give you the idea about the new topics and courses, guys. So this is the question. So next one is what? Simple one question in GATE exam last year. Watch this question. MSQ in electrical branch last year. New students, watch it carefully. In electrical GATE 2024. I think 2024 or 2023. I think 2024. Check it. Now this is the question. There are three diodes. Diode D1, D2 and what? D3. And one 2 ampere current source is connected. 4 ampere current source is connected. What 20 volt battery is connected, as well as one switch is also connected. That is the question. Okay. Why? And it is MSQ. So what is written here? When the switch S is on, when the switch S is on, when the switch S is off, when the switch S is off. So there are two positions. One, the switch is on, once the switch is off. Take a screenshot of that, try to solve. I will solve. I will solve. Think about it. What is the question here? It is a previous year question. It is a MSQ multiple select question. More than one answer may be correct. There is a switch, as well as there are three diodes are connected. Now, just I will solve this question. Before that, I have started, because now in engineering services exam, IRMS, Indian Railway Management Service, through what? Engineering services, ESE. Or is bar, what about the ESE? It will be in what? Month of June. Means after GATE you are going to get the sufficient time, right? That's why I have started with what? Super 5. Super 5 means 5 subjects for electrical, electronics and instrumentation branch, and digital for computer science branch. Then what? Super 5 live classes available on what app? We have some discount. You can save up to what? 40%. So use code SAVE40. First of all, download the app. If you find any difficulty, then call, message us, WhatsApp. जो भी आपको नंबर दिया हुआ है 9899940096, उस पर व्हाट्सएप करो, मैसेज करो, या आप कॉल कीजिए डायरेक्ट. देन ये है अगेन सुपर 4 फॉर इफ सपोज इफ यू वांट टू स्टार्ट विद व्हाट, स्टार्ट योर जर्नी विद अस विद व्हाट 4 सब्जेक्ट. तो यहां पर आप 4 सब्जेक्ट के साथ भी स्टार्ट कर सकते हो. उसकी डिटेल भी आपको मिल जाएगी. और जितने भी हैं पांचों सब्जेक्ट इंपॉर्टेंट है. सबसे इंपॉर्टेंट क्या है? आप बोलेंगे सर पूरा कोर्सेज अवेलेबल है, रिकॉर्डेड लेक्चर्स अवेलेबल है, व्हाट इज स्पेशल हियर? मैं आपको बता दूं, आप जहां भी ज्वाइन कर रहे हैं, व्हाट अबाउट द पर्सनल इंटरेक्शन, व्हाट अबाउट द डाउट क्लियरिंग सेशंस? इफ यू हैव सम डाउट्स, हु विल गिव द आंसर फॉर योर क्वेश्चंस? ये बड़ी प्रॉब्लम है. तो यहां पर आप आइए, 1-to-1 इंटरेक्ट करो, लाइव सेशंस अटेंड करो, रिकॉर्डिंग्स अवेलेबल है, प्रीवियस ईयर क्वेश्चंस के सॉल्यूशन अवेलेबल है, क्वेश्चंस फ्रॉम टेक्स्ट बुक अवेलेबल है, and what most important thing is what? Doubt clearing session. Okay, now some students demanded for what? Network and analog, or only analog. Yes, we have the separate subject, combo network plus analog, network plus digital. You can join analog plus digital, you can join, or you can also join the single subject. But remember guys, if you are going to join the super 5, super 4, no doubt you can save some money, but most important thing is what? You are going to get the top rank in this exam. 5 सब्जेक्ट में क्या है, कुछ आपको समझ में आएगा. और ये सब इंग्लिश में भी अवेलेबल है, हिंदी में भी अवेलेबल है. और दैट कंप्लीट कोर्स इन हिंदी एज वेल एज व्हाट? इन इंग्लिश. तो यू कैन ज्वाइन नेटवर्क प्लस एनालॉग, एनालॉग प्लस डिजिटल, और व्हाट? सुपर 5. ओके, तो यू कैन यूज द कोड. दिस इज फॉर लिमिटेड पीरियड ऑफर, SAVE40. राइट। अब आपके पास 2 महीने हैं, मंथ ऑफ व्हाट नवंबर, मंथ ऑफ व्हाट दिसंबर, एंड देन 1 month फॉर व्हाट रिवीजन। तो स्टार्ट योर प्रिपरेशन नाउ, बिकॉज नाउ वी हैव द गोल्डन अपॉर्चुनिटीज। कैसे? अब इन 5 सब्जेक्ट से आप अपनी प्रिपरेशन स्टार्ट कीजिए और उसके बाद गेट के बाद एकदम सिंसियरली भिड़ जाइए, तो इस बार आप इंजीनियरिंग सर्विसेज एग्जाम भी क्रैक कर सकते हैं, राइट। दैट विल बी इन इंग्लिश, राइट। If you want the classes, all the classes in English as well as in what Hindi, completely in English or completely in what bilingual, that is what Hindi. Okay, doubt clearing session again in English and Hindi both. So already I have started, you can join now and you can watch that some demo lectures also. Okay, go through the app, download the app, right? All the subjects are available, demo lectures are available, free classes are available, go through it. Then link is given in the description, and I am going to start one important session, guys. That is what complete digital for you, weightage, important topics, schedule on this YouTube channel. Concepts with what numericals, concepts with numericals. Now again I am going to start one important topic for you. For example, watch this question, guys, right? Watch this question. This is a question based on what? Multivibrator, because there is a positive feedback, one capacitor is connected in the op-amp circuit, the Zener diodes are connected here. Now this single question will take around 30 minutes. समझ में आ रही बात? 30 minutes to explain this question. लेकिन this question is very very important. Once you will get the idea why these Zener diodes are connected here, what is the role of the Zener diodes, then second, what is the role of the capacitor here, what is the RC circuit here, right? Then what is the role of this switching action, what is the importance of the positive feedback, why we are giving the positive feedback to the operational amplifier, and because of the positive feedback, operational amplifier will always in what saturation, it may be plus 10 volt or it may be what minus 10 volt. With single question you will get the command over multivibrators. That's why I'm going to start series where I will solve single question only. For example, this is the question, and with these questions you will get the idea about the Zener diodes, idea about the circuit, idea about the positive feedback, idea about what RC circuit also, network. This is the RC circuit. It is a combination of what network and what analog, and you will get the multiple concepts from this particular question. Don't try to mug up, try to understand this type of questions, guys. Okay, so I'm going to start, so please join that. It may be what live session or it may be what recorded, what you want, give me the suggestion, right? Similarly, for example, this is one question, this is the another question, what wind bridge oscillator. With this one question you will get the complete idea about the Barkhausen criteria and complete idea about the wind bridge oscillator, guys. So what are the limitation, what is the condition, why we are connecting, why we are giving the positive feedback as well as what negative feedback, what is the meaning of the Barkhausen criteria, how we are going to satisfy the Barkhausen criteria in this diagram, whether it is a non-inverting op-amp or inverting op-amp, everything we are going to discuss here. Okay, so that is the condition. This is the single question. Similarly, we have number of questions in what? Network also, right? Number of questions in network. For example, questions from Van Valkenburg, questions on transient, questions on Thevenin's theorem, questions on two-port network. With a single question you will get the complete idea about the Thevenin's theorem, not Norton's theorem. The single question you will get the complete idea about what two-port network. Okay, to watch it. So first of all, subscribe the channel so that you will get the video playlist and so on. Then okay, now finally, what is the answer for that question? I'm going to solve again 5 or no, this is the question. Okay, bolo kya hoga answer? What is the answer for this one? All the elements in the circuit shown in the following figure are ideal. Which of the following statement is are true? When the switch S is on, both the D1 and D2 conducts and D3 reverse bias. When the switch S is on, D1 conducts and D2 and so on. Then first of all, there are two positions, switch on switch off. So first you can choose what? Switch on. So switch on means let this switch is on. On means it will act as short circuit. And this is let ground. This is 0 volt. 0 volt. Now again there are 3 diodes. So total 8 condition, guys. But because the switch is on, this is 0 volt. What about the D3? D3 is off. This D3 is off. D3 off. Watch this D3 because it is a 40 volt 0 off. Now this current will pass through what? Switch. Okay. This is the 2 ampere DC current. Then now what about the D1 and D2? Now for D1 and D2 we have the 4 condition. 0 0 means off off, 0 1 means on off on, 1 0 on off, 1 1 both on. Okay. Now if you are assuming let both the diodes are on, because that 4 ampere current will pass, if you are assuming let both the diodes are on, first condition, D1 D2 both on, let it is assumptions, let if now it is on, try to understand, if it is on, guys, this diode is on, so what is the voltage at this point? This is the 20 volt, this is on, that's why it is a 20 volt. Okay. Now this is a, because that diode is on, we are assuming that diode is on, this is the 20 volt. Now this diode is also on, so if this will act as short circuit, so what is the voltage at 0, what is the voltage at this point? 0 volt. So my dear friend, at the same node 2 voltages are not possible. How is the 2 voltage not possible? Because this diode is on, because of this diode it is a 20 volt, because of this diode it is what? 0 volt. Not possible. But 0 volt is fixed here because this switch is on, and that's why this assumption is wrong. This assumption is wrong. D1 and D2 both are not on, and according to this D2 is what? Off. D2 is off. So what is the third assumption? Now this is on, this is 0 volt, because of this it is 0 volt, this is 20 volt, it is 0 volt, here it is a 20 volt, negative terminal voltage is greater than positive, and that's why this diode is off. What about the 4 ampere current? 4 ampere current will pass through this. What about the 2 ampere current? Switch is on. So what is the current through the switch? 4 plus 2, 6 ampere. And what is this? Off. So what is the current here? 0. This diode is off. So what is the answer? When the switch is on, D1 is on, D2 and D3 off. When the switch is on. When the switch is on, D1 conducts and D2 and D3 reverse bias. B is the correct answer. It means what about the A? A is the wrong answer. First, it is a MSQ. It is a MSQ, guys. So in exam hall, please take care of what time. Suppose you are going to spend what 10 minutes, then definitely if you are going to spend what 10 minutes or 20 minutes, remember what is the maximum mark you will get? 2 marks. So take care of time. कोई भी सॉल्व कर सकता है, लेकिन पता चल रहा है पूरा टाइम मैनेजमेंट गड़बड़ हो गया, इस चीज को बना रहे हो 15-20 मिनट निकल गए. Now second, when the switch is off, when the switch is off, guys, so what about this current? 2 ampere. 2 ampere can't flow like this, right? Then watch it carefully. When the switch is off, this diode is what? On. Like this diode is on. When this diode is on, because this 2 ampere current will flow through the diode. So what is this on? Short circuit. So what is the voltage at this point? 40 volt. What is the voltage at this point? 40 volt. Okay. Now if you are assuming let the diode D1 is on. All on. All on. That is on. D3 is on. D1 is on. D2 is on. So what is the voltage at this point? 40. If it is on, it will become 40. What is the voltage at this point? 20. So according to it, if it is on, then voltage at this point should be equal to what? 20. Not satisfied. At the same node, we are getting the 2 voltages, 40 as well as what? 20, because that is on. So from this point, it is 40 volt. From this point, it is 20 volt. Not possible. Then since the positive terminal voltage is 40, negative terminal voltage is 20, means what about the diode D2? It may be what? On. You can assume it what? On, right? Like this is on. Third condition, let D2 is on. D3 already on, D2 on, D1 off, and the switch is open. This will act as short circuit. What is the voltage at this point? 20 volt. What is the voltage at this point? 20 volt. What is the voltage at 40? Here it is 20, here it is 40. Definitely it is off. Our assumptions is correct. That 4 ampere current will pass through this. Out of 4 ampere, 2 ampere will flow here. What is the current through the battery? 2 ampere. Current through the battery is 2 ampere. This 2 ampere current will flow through this diode and again finally through the 40 volt battery here. 40 volt battery. This is the 2 ampere current. Now remember this 20 volt battery. There may be another question. What about the 20 volt battery? It will deliver the power or it will absorb the power? Tell me what is the answer. This 20 volt battery will deliver the power or absorb the power? What about the 40 volt battery? So what is the answer for this question? D2 and D3 on. D2 and D3 will conduct and D1 off. When the switch is off. When the switch S is off, D1 is reverse bias and both D2 and D3 conduct. No. When the switch S is off, D1 conducts, D2 is reverse bias and D3 conducts. D1 is reverse bias, D2 and D3 conducts. B, C. Answer for this question is B and C. So multiple diodes. Question based on what? Multiple diodes, guys. Now, once you have the current, remember, this battery, when the current enters through the plus leaving the minus, that will power is what? Absorbed by the battery. Power absorbed by the battery. For any element, if the current enters through the plus leaving the minus, power absorbed, VI. Power absorbed by the particular element. If the current enters through the minus leaving the plus, then it is power delivered, and that is power delivered is given by minus VI. Negative. Minus VI. According to sign convention, this is the minus VI. But simple word is what? What is the power delivered or what is the power absorbed? The power absorbed here. Okay. This battery will absorb the power 40 watt, 20 into 2, 40 watt. This 40 into 2, 80 watt is absorbed by the 40 volt battery. Now guys, energy can neither be created nor be destroyed. So what is the power delivered by this 10 volt? Because it will give the 4 ampere current. 4 ampere current. What is the power given by this? 10 into 4, 40 watt. What is the power given by the 4 ampere current source? Can you find? What is the power given by the 10 ampere current source? Okay, so that may be the question, guys. Okay, the important question. This is the 2 ampere battery. What is the power delivered by the 2 ampere battery and so on? Network. Question based on network. You have to satisfy the Telegon's theorem. Power delivered plus power absorbed. What is the total summation of the power? 0 according to Telegon's theorem. Now, this is question based on what? Multiple diode. Now, question based on what? Single diode, guys. Question based on single diode. Watch this. Some students are new here, so watch the very simple question. Find the current I, assume the ideal diodes. If this is the current given, this is ground, single diodes, ideal diodes. It may be practical diode, it may be silicon diode, or we have the different types of question. Let first of all assume the ideal diode. If it is ideal diode, on the positive side 10 volt battery is connected. If on the positive side 10 volt battery is connected, means we can assume that the diode is on. If you are assuming the diode is on, find current I, and that current should be positive. That current should be positive, guys. So first, let the diode is on, it will act as short circuit. Now, in a very simple, you can find what voltage at this point, V. Apply the nodal, V minus 10 by 5. Nodal equation, V minus 10 by 5. V minus 0 by 10. V minus 0 by 10. V minus 0 by 10 is equal to 0. This is called nodal equation. 10 is the LCM. 2V minus 20 plus V is equal to 0. 4V is equal to what? 20, because 10 will become 0. So what is the V is equal to 20 by 4? 5 volt. If this is 5 volt, so what is the value of the I? Tell me. 5 minus 0 by 10. 1 by 2 milliampere. Why? Because it is in kilo ohm. Positive current, and that's why this diode is what? On. This diode is on. So voltage, because it is short circuit, so what is the voltage at this point? 5 volt. Voltage at this point is 5 volt. Please check my calculation. Very simple. You can also find the R equivalent, guys. This 10 kilo ohm are in parallel, 5 kilo ohm, 5 kilo ohm, 5 kilo ohm series. So what is the current given by the 10 volt battery? 1 ampere. Quickly you can also solve. This is the 5 kilo ohm. 10 and 10 are in parallel. What is this? 5 kilo ohm. This is the 10 volt battery. So what is the R equivalent? 10. So what is the current given by the battery? 10 divided by 10, 1 ampere, 1 milliampere. Now, this battery will give the 1 milliampere. So, according these two resistors are same, it is equally divided into two parts, 1 by 2, 1 by 2. So, answer for this question is 1 by 2 milliampere. Very simple, you can find, whether it is nodal analysis or so on. It depends upon your command or what network or circuit theory. जितनी ज़्यादा आपकी command होगी उतनी तेजी से solve करोगे. एक बार आपको पता चल गया diode is short circuited. Means what? It is a question from network, right? ऐसे questions आएंगे, don't worry about that. Suppose the same question if you are going to assume, let the diode is what? Silicon diode. Then what will be the change? Silicon diode. But for example, this is the case. Same question, everything is same, 10 kilo ohm, 10 kilo ohm, 10 volt, 5 kilo ohm. What about the current? Tell me. If the diode is ideal, I was 0.5 milliampere. If now I am going to use the silicon diode, what about the current? Greater than 0.5 ampere? Less than 0.5 milliampere? Equal to 5 milliampere? None of this. Right, tell me. क्या यही तो होंगे 3 cases. I greater than 0.5, less than 0.5, equal to 0.5 milliampere. What about the current? It will reduce or it will increase? If you are going to consider the silicon diode, remember guys, for silicon diode, it is a practical diode. If it is on, what is the drop across the silicon diode? 0.7 volt. If it is off, it will act as what? Open circuit. Will act as what? Open circuit. Because of the 10 volt, the diode is on. But the diode is what? On. Then simply you have to replace the diode by what? Battery. 0.7 volt battery. Don't worry about that. Simply replace the diode by 0.7 volt battery only. Don't worry about the practical diodes. 5 kilo ohm, 5 kilo ohm, and this is what? 10 kilo ohm, sorry, 10, 10, 5, no, okay. What is the current here? You have to find. This is the 0.7 volt battery. This is the 10 volt. Now question from network. Find the value of I. Find the value of I. So one student have given the answer. Akhil B. Current decreases less than 0.5 milliampere. Yes. Now we will check. Less than 5 milliampere means what? You can if you want to find the current I, you can find the Vx. Apply the KCL. Vx minus 10, nodal equation. Vx minus 10 by 5 plus Vx minus 0 by 10 plus Vx minus 0.7. This voltage will oppose the Vx minus 0.7 upon 10. You can subtract here. This is the battery is equal to 0. You can take 10 as a LCM. Then it will become 2Vx minus 20 plus Vx minus 0.7 is equal to 0. Now 4Vx is equal to 20.7. 4Vx is equal to 20.7. So what is the Vx is equal to 20.7 divided by 4 volt. Right, 20.7 divided by 4 volt. What is the current I? I is equal to Vx minus 0.7. Vx minus 0.7 upon 10. So what is the Vx? 20.7 divided by 4 minus 0.7 upon 10. What is the value? Please calculate it. Please calculate if you have the calculator. What is the answer? What is the answer? You will definitely get the current less than what? 0.5. Calculator. Use virtual calculator only. Calculator. Yes. .4475. So when it was the ideal, what was the answer? 0.5, and now it is the less than 0.5 million. So my dear friend, that is the use of what ideal diode and what practical diode. When we are assuming the practical diode, definitely the current will what? Reduce through that path, right? But if suppose it is asked, what was the current through the 10 kilo ohm initially when it was the ideal diode? When it was the ideal diode, the current here 10 minus that current was 1 milliampere, then 1 by 2, then 1 by 2. But once you are considering the practical diode, what about the current through the 10 kilo ohm resistor? Increases or decreases? So guys, if you have the value 20.7 by 4, 20.7 by 4 upon 10. Now you can find the current through what? This one, 10 kilo ohm. Definitely, what about the current? Increases. You can check here. 20.7 divided by what? 4 divided by 10. So what is the current? 0.5175. This current increases, that current decreases. Right? And what is the current through this 5 kilo ohm resistor? So you can also find 10 minus 20.75. Definitely the battery will give the less current because we have the voltage drop across the diode will oppose the battery. So battery will give the less power, less current. What is the value? .965. Less than 1 milliampere. My dear friend, this current decreases, this current increases, and that current increases, this current decreases. So what I want to say, before solving, without solving the question, you No doubt, this current will reduce, but what about the current through this 10 kilo ohm resistor? It will increase. That is the logic. Okay. So to find the voltage at this point, you can directly conclude. So what is the difference between the ideal diode and what practical diode? So in one question, in one single question, we have the multiple ways to solve this question. For example, same question, find the current I for the following characteristics of the diode. RF is 100 ohm, V gamma, cut-in voltage is 0.5 volt, and this is the characteristics. This is the large signal model of the diode. If that diagram is given, guys, if the cut-in voltage is given, RF is given, then remember, diode, if it is forward bias, it should be replaced by what? V gamma and RF. What is the V gamma? 0.5 volt. And what is the RF? 100 ohm. Means 1.1 kilo ohm. It should be replaced by 0.5 volt and 1 kilo ohm. Because of this 10 volt battery, the diode is on. Because of this 10 volt battery, the diode is on. So what is the practical condition? You have to replace this diode by V gamma and one RF, and then this resistor. This is the 10 kilo ohm, 5 kilo ohm. This is the 10 volt battery. This is the 10 kilo ohm. This is the 0.1 kilo ohm, and this is the V gamma. What is the V gamma? 0.5 volt. Right. Now what will be the question here? You have to find the value of I. Yes. It is very easily you can find the value of I, but first of all apply the KCL here. Vx here. So nodal equation Vx minus 10 by 5, just I am giving, try to solve this. Vx minus 10 divided by 5 plus Vx by 10, Vx minus 0 by 10 plus Vx minus 0.5, this is the 0.5 upon 10.1 is equal to what? 0. You can use the nodal equation, you can use the mesh analysis or anything. You have to find the answer here. Then you can find the Vx. Once you have the value of the Vx, what is the current? Vx minus 0, Vx minus 0.5 upon what? 10.1 will give the value of I. Second question, what is the drop across the diode? If the drop across the diode is asked, always find drop from this point to this point. This is called the drop across the diode. What is the voltage drop across the diode? So Vd will become V gamma plus I into RF. V gamma plus I into RF. This is the RF forward resistor. This is the V gamma cut-in voltage. Then you have the value of I, you have the value of RF, you have the value of V gamma. Then you can find the value of the voltage drop across the diode. Okay. So that may be the question. This is assignment for you. Try to solve it and write the answer in what? Comments. Already I have given the hint, everything. Hope you have enjoyed the session, guys. So again, there are multiple questions on what? Diode, right? So I am going to start this series. Single question, complete concept. Okay. So we will discuss this type of questions. Within 30 minutes, you will get all idea about these questions. You will get the basics idea about the topic. You will get the command over the concepts. Okay. एक बार अगर आपका कॉन्सेप्ट ठीक है, बेसिक्स ठीक है, तो कोई भी क्वेश्चन आप बना सकते हो. ऐसे क्वेश्चन आपको परेशान करते हैं क्योंकि यहाँ पर बहुत सारे कॉन्सेप्ट लगते हैं. ये भी लग गया, जेनर डायोड भी लग गया, रजिस्टर भी लग गया. देयर इज अ पॉजिटिव फीडबैक. So we have to handle the number of concepts. So don't worry about that. This is a very conceptual question, right? Then I'm going to start what? Digital for you, complete digital on same YouTube channel. So all the new students, subscribe the channel so that you will get the notification. This is the session this weekend on Friday. What about the weightage? What about the important topics and schedule? Then tomorrow you can get the command over what? Two-port network, Z parameter, T network, and what? Pi network, Z parameter and Y parameter. So watch that session tomorrow, right? Then after that, this is a general session and I'm going to start the smart revision series for digital, from number system to what? Combinational circuit, sequential circuit, and A to D, D to A converter, as well as logic family also. And these are the courses on our app, Super 5 and Super 4. These are the features of our courses, and there is some Diwali offer. You can save up to what 40%, so please go through it. Download the app. A link is given in description. Number of free sessions are also available on the app, and you can also give your suggestion also. PDFs are available, notes are available, class notes are available, right? My 400-page notes for what analog, microwave, microprocessors are available on what our app. You can download there. Okay then. So some students ask about the individual subjects or what combination combo. So that is network plus analog, analog plus digital. You can join. All courses are what in English as well as what in Hindi. Completely in English, completely in what? Hindi. Okay. Hindi means what? English. Hindi plus English, but completely in English also. So you can ask for all these. Okay then. Thank you very much for attending the session, guys. Subscribe the channel and like the session. Thank you.